So let's look at some more examples of getting Desmos to find Extrema for us. And the function, I'm going to continue in Chapter 4, Section 1. We're going to look at the things between 45 and 52. We're going to look at some things that might not be as obvious to find our Extrema on. So let's look at 48, where we have some function of x, where we have negative x to the fourth power plus 4x cubed minus 4x squared. Now, looking at this function itself, I don't see any obvious ways to see the extrema. So what we're going to do is we're going to come over and we're going to graph this in Desmos. So let me get my Desmos window in front of me here. And so I'm going to do f of x is equal to negative x to the fourth. Remember, to get a power, it's shift 6. I'll bring the keyboard entry down here. And then what do we have? Plus 4x cubed minus 4x squared. And so looking at this function, we can see that we have 3 extrema, which we should expect 3 turning points because it is to a fourth power. There's at the most 3 turning points. And so what we want to be able to do is we want to look at if there are any maxes or mins coming across. Well, these will be local maximums at 0 because the y value is 0. They're also the absolute maximum. This function never, ever, ever, ever gets bigger than 0. And we have a local minimum at negative 1. Now notice how Desmos finds these turning points for us and highlights them and gives us an ability to look at this. So it's just like what a graphing calculator does. You can move the cursor about on the graphing calculator. And so this utility can help us find our extrema. All right, let's look at another function here, and I'm just going to put it straight in for us. And I'm going to look at 46. 46 is an odd function. I shouldn't say odd as if it's an odd function, even or odd, but it is 1 over 1 plus the absolute value of x. And so we get an interesting function here. It has this kind of curved, and it comes to a cusp. We use the technical word for that. And we have a local and absolute maximum at 1. It rises and the y value here is 1. And so we have a local maximum and it's an absolute maximum. Now this function never gets smaller than 0. You can't get this function to be 0, but it never gets to 0. So we actually don't have an absolute minimum. It will keep getting smaller and smaller and smaller. It does tend to have a limit as we go off to infinity, but you can always get a smaller number out of it. You just can't get it to 0. All right, and let's look at the last one I'm going to look at here. It's going to be number 52. And so 52, let me turn this one off, is f of x is equal to 6 divided by x squared plus 2x plus 2. And so we get this nice peaked function. It's shifted a little bit over. And we can notice here that we have a maximum, a local maximum, and an absolute maximum at 6, because that's the value it would reach at 6. Again, it can never get to 0. It can get smaller and smaller and smaller and never to 0, so it does not have a minimum. All right, these are the videos I wanted to show on finding extrema and how we can use our graphing software to work with it. I'll continue to make videos showing different things in Desmos where I'll enter the things off on the side here and show the utilities for looking at them. And we'll practice with this because it will really, really help us kind of get used to what our functions do. Once you start seeing a lot of these functions over and over again, some of their behaviors will become predictable for you. And I'm hoping this graphing utility can help you find some of those patterns.